In this video, we are writing a program to find the sum of first 10 integer numbers. Here, as we know that whenever we start writing any program, we need to write this line, that is to define the area within our memory. So we will define this area. Next, we need to give the area name. As we are finding the sum of first 10 integer numbers, we will give the name for this area as sum. Next, we will define that some area of this memory area is a code memory. That is, we are writing a code in that area of sum. Next, this code memory is read-only memory. Here in this program, we are adding first 10 integer numbers, that is 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8, 9 and finally 10. We will get the answer as 55. 55 is the sum of first 10 integers, that is 1 to 10. This 55 is equivalent to 37 in hexadecimal. We know that in microcontroller, whatever the value will be getting, that will be in terms of hexadecimal. So the equivalent of 55 is 37 in hexadecimal number. So first, writing the program, we will set the counter as a 10. That is, we will write a instruction move R0, #10. That is, we will have in R0 10 decimal number. We will use this counter for adding purpose. That is, we want to add 10 integers. That is why we have taken the counter. If we are adding 5 integers, we are using this number as 5. As we have 10 integers to be added, we have taken the counter as 10. Next, we will initiate the register to store, because this is the end. Whatever we add, the result should be stored in some register. So we will initialize that register as R1 and we will initialize with the value of 0. So for that, we will write move R1, #0. So now in R1 we will have a value 0. Next, we will take the first number to be added, that is 1. So we will move it to R2 register, so that move R2, #1. We'll copy 1 into the R2 register. We will add these numbers, that is, we will write the instruction add R1, R2, so that it will add R1 plus R2 and the result will be stored in our result register, that is R1. That is 0 plus 1, it will be 1, that is stored in the register R1. Next, we will increment the register so that we need to add the next number, that is what we have taken integer in R2. So that number should be incremented, so that we will add R2, 1. So previously in R2 we had 1, we will add one more value, that is it will become 2. So that we are adding the next integer. Now we will decrement the counter, because we have added a first value, we have done with the first value. Now the remaining are 9 values. So we need to decrement our counter. We will write sub, that is R0, 1. So R0 value, that is counter value, will be subtracted with 1, that is 10 minus 1. It will become 9. We will check whether this counter is 0 or not. So that if it is 0, we have done with all the integers. Now the counter is it is 9. So we need to go back and add the next number. So to check that, we will write an instruction branch if not equal, and it should go for the next addition. That is, if R0 value is equal to 0, then it will come out of this loop. If it is not equal to 0, that is NE, be any branch if not equal. So not equal to 0, it will move to the next label. That is, we will go with the add instruction. Now the value add R1, R1, R2. So what we have in R1, 1 in R2, we have 2. So we will add 1 plus 2 plus and the result will be in R1. It will be previously we have R1 1 and R2 2. Now after adding we will have the value in R1 as 3. Now we will increment the integer 2 3. Next we will subtract the counter, that is we will decrement the counter. Previously we had 9, now it will be 8. Next again we will check for this counter value whether it is equal to 0 or not. If it is 0, if it is not 0, because now it is 8, so we will check here. It is not equal to 0, it will go back to this instruction, that is add instruction. So we will add this value again and again. So in this loop we will have the value R1 will be 6, R2 will be 4, R0 will be 7. That is previously we had R1 is 3, R2 is also 3 plus 3. Now 3 plus 3 we will get the answer as 6. R2 is incremented, that is next integer, that is 4. Counter is decremented from 8 to 7. So whether the counter is 0, no, it will go for the next loop in this loop. So we will add 6 plus 4, that is 10. It is equivalent to the hexadecimal. Now we will increment the next integer, that is previously we had 4, now it will be 5. The counter was 7, now it will be decremented to 6. So whether this counter is 0, no. Again this will go to the next loop. So here we will add these previous values, that is a plus 5 are 10 plus 5. 10 plus 5 is 15, that is equivalent to F in hexadecimal number. So now we will add R2 value with 1, that is we will increment the next integer, that is 5 plus 1, it will become 6. Counter will be reduced from 6 to 5. So now it is not equal to 0, again it will continue with the same loop. Now it will add 15 plus 6, that is 21. It is equivalent to 16 in hexadecimal. Next integer will be from 6 to 7. From 6, now it will go to 7. So we have a counter 5. It will be decremented to 4. So this counter is not equal to 0. So it will jump for the next value. That is, it will add, when previous value we had 21, now we will add 21 plus 7. It will become 28 and it is equal to 1C in hexadecimal. Now we will increment the integer value, that is from 7 to 8, and we will decrement the counter from 4 to 3. So now the counter is not equal to 0, it will jump to the loop again and it will be executed. So now we'll have 28 plus 8, so it is 36, which is equivalent to 24 in hexadecimal. Next integer we need to add is 9 and the counter is reduced to 2. So again it is not equal to 0. The loop will start and we will add 36 plus 9 and it will become 45. The next integer is 10 and the counter is decremented from 2 to 1. So it is not equal to 0. Again loop starts to work. Now it will add 45 plus 10 and it will be 55. And the counter will be decremented and counter will become 0. So we see here B and E equal to BE instruction. The counter is equal to 0. Now it will jump to next label. It will come out of the loop and it will stop that loop. Once this loop is stopped, we have a value of R1 equal to 55, that is equivalent to 37. we can observe on the top that we had 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, which is equal to 55, equivalent to 37 in hexadecimal. So we have that value in R1 register. So we write a no operation instruction so that it does not do any operation. Once this program is done, we'll stop this program by writing an end directing. So now we will write the same program in Keel Microvision software, and we'll run this program and check whether we are getting the same value. To write the program and to execute that program, we need a Keel Microvision. We'll open this Keel Microvision window. We'll start writing the program. To do that, we need to create a project. So we'll select this project from the menu. Now we'll select new Microvision project. Here we have created a folder called as ABC in the desktop. In the same folder, we are creating this new project. So we'll give the name sum. They will save this. So now we are writing the program. We need to define the target. We are using LPC2148. So we will select that and click OK. So it will ask for a startup file. So we don't need the startup file now. So we call no. So now we can see here we have created a target and we have a source group. So now to write the program, we need a blank file. So we click on this new file icon. So in this new file, we are going to write our program. Before writing, we will save this file. Click on save on the same folder, that is ABC. We'll create this file. We'll save the file as sum, and extension should be .asm because we are writing the code in assembly language. That's why we have the extension as .asm. We'll save this file. Then we need to add this file to our source group. We'll right click on the source group, select add existing file. We need to add our sum.asm file, so that we need to select here ASM source. Now we will select sum and we will add this sum file. Now we can observe that we have added sum.asm to our source group. Now we will start writing the program. This entry start is a label, next is also a label, stop is also a label. So except these, all other this is directives, and all other instructions should be written after a tab. So once we write the program, we will save this program and select the windows. Now we will build this program. It will check whether we have any errors or warnings. We can see here we have 0 errors and 0 warnings. In this debug window, we can see that we have a registers. So in that registers, we have all the register values are 0. Now we will fill with this our values, that is in the first instruction. We will move the value R0, 10 to R0, that is hexadecimal, A to our R0 register. We will debug step by step. We click on this step icon that we get a value in R0. Now 0 is moved to R1. It is already 0. That's why it is not shown. We will move R2 to 1 so that 1 is moved. Next we will add R1 and R2, that is a 0 plus 1, and the result will be stored in R1. Now we will increment this R2, it will become 2. We will decrement the counter, R0 value A. So A is decremented by 1. That will become 9. So it will check whether this R0 value is 0 or not. If it is not equal to 0, it will go to the loop next. We can see that the arrows indicating it has been sent to this next. Now it will add R1 plus R2, that is 1 plus 2, it will be result, that will be 3, and it is stored in R1. Next, there is decrement in a counter, so it will again do for that same loop, and it will do the addition until they have this counter value as 0. Now the counter value is 1, so it will decrement the counter. Now the counter value is 0, so that it will come out of that loop. So you can see that it has come out of that loop and it is now pointing to the no op instruction. At this time we have a result in our R1 register, that is R1 register we have 37. As we have seen of integers 0, 1, 2, 10, if we are adding 10 integers, we get the value 55, which is equivalent to 37 in hexadecimal. We are getting this 37 in our result register R1. To stop this debugging, we'll click on this stop, the work session icon, that will come out of this debug session. We have written a program to add first 10 integers and we have verified so that the value will be 37 hexadecimal number, and it is stored in our result register R1.